So last week we talked about epidemiology and how it can relate to a needs assessment. So today we're going to talk about the measurement techniques that we use and what's important when you're measuring in order to gather the data you need. Measurements is defined as the process of applying numerical or narrative data from an instrument. This is going to be specific to the kind of data you want to collect. The proper measurement tool should be identified based on what information is most relevant for your needs and how it's going to be categorized. Data can be classified into two categories, quantitative and qualitative. I know we discussed this last week, but I'm just going to go over it a little bit again. Quantitative is numerical data collected to understand individuals' knowledge, understanding, perceptions, and behaviors. This is examples of this can be BMIs, prevalence of marijuana use among specific populations, and pre-test and post-test scores. Like we talked about last week, these are measurable numeric data, while qualitative data is data collected with the use of narrative and observational approaches to understand individuals' knowledge, understanding, perception, and behavior. This is usually more words that are organized into themes or codes. Observational studies are a big example of that. It's just more narrative. An example that has always helped me to remember the definitions and the differences is painting or decorating a room. If you're defining that quantitatively, you're going to say, I painted two walls, I hung four drapes, I added a chair. If you're going to define it qualitatively, you're going to say, I painted the walls a buttercream yellow, I hung beige curtains, and I added a gray lazy boy. Both provide important information, but in two very different ways. Each separate description has information that you need in order to understand the project, but together the information has greater strength. It is really important to understand how to plan and carry out measurements when you're developing your health promotion programs. Even if you're not specifically gathering the data, it's very important to understand what we desire in measurement tools for many reasons. And one is that the data generated by measurements must be properly understood. A planner should be able to understand this data and determine if it's accurate and thorough enough to justify the program. It's also important to properly select your measurements. You need to understand what's desirable in measurements, which we're going to talk about later, in order to select what's appropriate. Outcomes also need to be measurable. You have to create outcomes that you can measure in order to know or be able to evaluate your program. And it also provides evidence of effectiveness. It'll be necessary to prove that your program is making a difference, and measurements allow for that. And then finally, to understand the results correctly. It allows for an educated response to your questions about the program. 70 years ago, psychologist Stanley Stevens developed 4 levels of measurement that are still the basis for all scientific measurement today. These measurements are all considered hierarchical, which means that they start simply and progress to more complex measurements. We'll start on the bottom here with nominal measurements. This is the lowest level of measurements, and they are kind of used, they're names or labels that you use to categorize people, places, or things. They do show different categories, but they do not show any specific order or value within those categories. The requirement is that each category be exclusive from the other, and there has to be a category for every single option. The next step up is ordinal, and this builds on the nominal level measure. It is defined as the differences are that there is a rank or order to all the categories, but that rank is not measurable. A familiar example is the pain scale. We all know this one pretty well. There is a rank 1 to 10 that you do pick a specific category, and they are in order, but there is no measure between those ranks. The difference between pain level 1 to 3 may be different than the difference between pain levels 5 to 7. The next level is interval level measures. This is going to build again on the previous level measures. And this is where the data is in categories that are mutually exclusive and exhaustive. You can rank the categories and it's continuous. So that means all the differences in the ranks are the same. But the big thing here is that there's no absolute zero. A good example is time of day. Each hour is exclusive and exhausted because each hour is the same difference. 11 to 12 p.m. is the same amount of time as 4 to 5 p.m., but there's no 0 o'clock. There's no absolute zero. And finally, the ultimate is the ratio level measure. This builds on all three of the previous level measures, but it contains an absolute zero. A good example is your GPA. Is a ratio level example. There are specific categories and they have a specific continuation in between them, but they have an absolute zero. You can get a zero GPA. None of you will, but it is possible. As well as your years of work experience is another good ratio level of measurement. It's really important to understand what people find as far as desirable characteristics of data. You want the data that you collect to be valid, reliable, and you want it to actually help you. You don't want it to be bad data. The results of any assessment is only as good as the data that is collected. So it's important to understand the desirable characteristics of data, and that is the foundation of a good health promotion program. There are many different types of measurement tools, and there's a need to be able to separate the bad information from the good information. And this is where psychometric qualities come into play. And those psychometric qualities are reliability and validity. Reliability is the estimate of the extent the instrument produces the same result time and time again. This is consistency in your measurement process. There are levels of consistency within reliability. Internal consistency is the intercorrelation of items within the measurement. Are they measuring the same? Do they reflect what is being measured? Stability reliability is that consistency over a period of time. Does the same measurement or does the same instrument measure the same group at two different points and yield the exact same results? This is your test and retest or your pre and post tests. Rater reliability is the consistency between individuals observing the same item. This can be consistency in between two individuals or a consistency between one individual itself. So when it's inter-rater reliability, that is when there's two or more individuals, and are they identical when they're measuring? Does each individual measuring exactly the same way as the other one? And intra-rater reliability is when one individual is observing, and do they observe the exact same thing every single time? So it's one person observing, but is every single thing they're observing, are they categorizing it in the exact same way? A good example or an issue with this is when you're measuring periodontal issues. Can we really say that two or more hygienists are reliable enough that they are measuring the same pocket within each other in exactly the same way? Or for that sense, even bleeding upon probing, are they measuring that exactly the same way amongst each other? Or even is one hygienist capable of measuring exactly the same time every single way? Every single patient, a 3 millimeter is exactly the same. No difference at all. So this is an important reliability to understand when you're thinking about like a periodontal measurement. And you also have equivalence reliability, which is, will all the different forms of the tool produce the same result? So if you're using a tool that has been created, is each single one that's created calibrated enough to produce the same result? Validity is, does the tool measure what it is supposed to measure? This removes all other explanations for the results. So within validity, you have face validity, which is the lowest level, and that is, does it seem on the face value to measure what it is supposed to measure? Very important. Content validity is all essential elements are measured. So if you want to measure dental caries, for example, then you need to note all elements to that, which is decay. Are they missing? Is it filled? Is it sealed? Without one, you're missing data about your content. We have concurrent validity, and this measure predicts the status. Mental health questionnaires is a good example of this. So if it's a concurrent validity, is the tool itself able to predict the status of an individual? If you take a mental health questionnaire, you can sometimes tell if somebody has a mental health issue, which is a little different than construct validity, which is, does the test measure the underlying issue? Anxiety tests don't really flat out ask you, are you anxious? But they do measure the level of your anxiety. And within construct validity is convergent validity. And this is the type of construct is a type of construct validity, and that is do the two measures correlate. We also have sensitivity and specificity, which you may already be familiar with. Sensitivity is how many true positives does that test get? Does the tool correctly identify those with disease? While specificity is are there any true negative cases that are identified? An example of this is Velscope. I'm sure some of you use it, some of you may not, and some of you may not be using it because it does have a low sensitivity. It does collect many false positives. The issue with Velscope, and if you're ever really interested in the sensitivity or specificity of Velscope, I have written a nice thorough paper on it, which all the current data that is available to the Velscope up to 2015. But do we have any other tools that we can really use? So yes, it does generate a lot of false positives, but do we have any other tools that can find any disease or any abnormalities before our eyes? And at this point, we really just don't. So it's kind of one of those issues that gets a little mucky. Let's discuss reliability and validity together. So the targets are a great example. You can have a tool that is reliable but not valid, as in this target, where the measurements are all consistent, they're all in the same area, but they're not where we want them. They're not on that bullseye or on the target. You have valid but not reliable, where the tool is all on the target and it all circles around a specific core point or core issue, but it's not reliable because they're all over the place and they're not in a consistent manner. Then you have the tools that are neither valid nor reliable, which you should never use. And those are the ones that are not focused around the target, and they're also not consistent or together. Your desirable form of data collection is going to be both valid and reliable. It's going to be focused on that target, and it's going to consistently hit the bullseye. That is it for measurements for today. Hopefully this discussion will be helpful for you for your discussion when you're trying to think about what the future of measurement might look like or how to improve dental measurement tools. I am very much looking forward to this discussion posts and to see what you guys come up with.